In this section, we're going to look at our first of two algebraic methods for solving systems of linear equations. So let's review just briefly. Remember, a system of linear equations is a set of two or more linear equations that are solved simultaneously. Okay? The solution to that system is the ordered pair that satisfies both equations. And what we learned in the previous section is that ordered pair is very specifically the point where the two lines intersect each other. So it's that point of intersection that we're interested in. Now, in the previous section, we learned how to solve systems of equations by graphing, which was really nice because we get this nice visual understanding of what is happening with a system. You have these two lines that are graphed in the same Cartesian plane. We pinpoint where they intersect. That's your solution. We also learned that there are special systems where there's no solution or there's infinitely many solutions. But generally speaking, we have this one point of intersection, and that's what we're looking for. We also learned that graphing by hand is maybe not always ideal because, human error can come into play. But if we use a graphing utility like Graphing Calculator or Desmos, it can be really powerful. So I do want to, in at least one of these examples, maybe just one, just for the sake of time, I do want to remind you how to use Desmos so you can check your answers. Now, Desmos is powerful. Don't overuse it, but it can certainly be used as a tool to check your work. Okay, so let's talk about topic one, which is solving systems using the substitution method. Okay, so I'm going to kind of read out and explain what's happening, but I don't expect it to fully make sense until we actually do a problem. So just kind of hang tight and I'll explain each of these steps again as we do them in the problem. Okay, so the idea behind the substitution method is you have two equations and two variables. That's beyond what we know how to solve. Okay, unless we graph. So what we're going to do is we're going to find a way to convert this system of two equations and two variables into a single equation and a single variable. Okay, and so to do that, what we do is we take one of the two equations and we solve it for one of the two variables. Doesn't matter which. However, be kind to yourself. Look for a variable that has a coefficient of 1. That's always going to be the easiest. -1 is always the second easiest, okay? Because a lot of times when you solve an equation for a variable, you end up with fractions, and fractions just complicate things. So always look for the coefficient of 1 or -1. Once you do that, take the result for that variable and plug it into the other equation. And that's what creates that single equation in a single variable. And then you solve that. That'll give you the value for one of the two variables. And then you use that, you just back substitute it into one of the original equations and you get the second variable. You can check your work and you write your answer as an ordered pair. So let's do this actually with an example so you can kind of see what those steps are doing. Okay, so example one says, solve each system of linear equations by using substitution. Write the answer as an ordered pair. So part A, our system is 2x minus 3y equals -13. And then we have y equals 2x plus 7. Well, in this case, part of the work has been done for you. If you notice that second equation, y equals 2x plus 7, it's already been solved for a variable. We have y equals, okay, so we know what the value for y is. It's just 2x plus 7. So what we want to do with this 2x plus 7, which is equal to y, we want to plug it into the other equation. So we want to plug it in to the first equation here for y. Okay, so let's rewrite that first equation. We had 2x minus 3, but remember, y is 2x plus 7, and then that equals -13. So here you can see that substitution that has taken place. We solved that second equation for y, or it was really already solved for y for us, and we took the result and we plugged it into the first equation, and now we have a single equation and a single variable x. This is something that we know how to solve, so solve it, okay? So I need to distribute the -3 through the 2x plus 7. So I'm just going to rewrite 2x, and then I distribute my -3. So -3 times 2x, well, -3 times 2 is -6. And then just multiply that by x, we get -6x. -3 plus 7 is, or plus 7, -3 times +7 is -21. And that all equals -13, okay? So now we want to combine like terms. If I look over here on the left-hand side of this equation, I have 2x minus 6x. I can combine that. 2 minus 6 is -4. So that leaves me with -4x minus 21 equals -13. Okay? Now, my goal is to get the 4x or the -4x alone. My issue now is that -21. So I want to go ahead and add 21 to both sides of the equation. On the left, negative 21 plus 21 is 0. Negative 4x plus 0 is negative 4x. And then on the right-hand side, negative 13 plus 21 ends up being 8. So I need to now, at this point, get the negative 4 and the x separated from each other. So I need to undo that multiplication. We undo multiplication with division. So I divide both sides by negative 4. Well, the negative 4's cancel to just become 1. Negative 4 divided by itself is 1. 1 times x is x. And then 8 divided by negative 4 is negative 2. So remember, we're looking for an ordered pair that represents the point of intersection. We now know that the x-coordinate of that ordered pair is negative 2. Now let's figure out what the y is. Go back to one of those original equations in your system, and we're going to substitute x for negative 2 because we now know x is negative 2, and that'll give us a value for y. So I'm going to use that second equation because it'll be nice and easy. So I get y equals 2 times x, which we know is negative 2, plus 7. So negative 2 times positive 2 is negative 4, and then negative 4 plus 7 is 3. So we now have the solution to this system of equations, okay? Now you can check this two ways. You can take this ordered pair and you can plug it algebraically into each of those original equations in the system. So plug in your x coordinate is negative 2, your y coordinate is 3, and as long as that ordered pair satisfies both of the equations simultaneously, you're good, okay? The other way you could check this is to jump over to Desmos and just type in both of those equations and see what the point of intersection is. So that's what I'm going to show you because I do want you to know how to use Desmos. So let's see, where's Desmos? Right here. Okay, so here we have Desmos. Let me move some stuff around on my screen. Okay, so it's just desmos.com. We've used it a couple of times already. You go to Open Graphing Calculator, and you just type in your first equation. Our first equation was 2x minus 3y equals negative 13. So that's our first equation. And then just hit enter and it'll pop in another line where you can type in another equation. The second equation was y equals 2x plus 7. All right, so there are the two equations. And if we look at this point of intersection and just hover over that dot, it tells us that the solution is negative 2 comma 3. And that's exactly what we got when we solved this by hand. Okay. All right, let's look at part B, okay? So we're back to the worksheet, and part B, we have the system negative x plus 3y equals 10, and then we have 2x plus 8y equals negative 6. We need to solve one of these two equations for one of the two variables, and to me, the one that seems like it'll probably be the easiest is the first equation, solve it for x, but you could, in this case, solve either of them for x or y. It doesn't matter. I just like that I'm going to have not as much work for that first equation. So over here to the side, I've got negative x plus 3y equals 10. I want to solve for x. That means I need to get that negative x alone first. The issue is the 3y, so I'm going to subtract it. 3y's become 0, leaving me with negative x equals negative 3y plus 10. But I can't have a negative x. I need to solve for x. That means I need a single positive x. So I can divide everything by negative 1, and that leaves me with x equals 3y minus 10. So this value right here for x, I'm going to take it and I'm going to plug it into the second equation for x, okay? So when we do that, we rewrite the second equation. We get 2 times x, which is really 3y minus 10. And then we had plus 8y equals negative 6, okay? So we're going to solve this equation now because we have a single equation in one variable y. So I'm going to distribute my 2 first. So I distribute the 2 through the set of parentheses. So I get 2 times 3y, which is 6y. I get 2 times negative 10, which is negative 20 or minus 20. And then I had 8y equals negative 6. We want to try to combine like terms. So I have 6y plus 8y. Well, 6 plus 8 is 14, so that gives me 14y minus 20 equals negative 6. I need to get the 14y alone, so I would need to move the 20 with addition. So the 20s, they cancel to become 0. That leaves me with 14y equals, well, negative 6 plus 20 is 14. Now I need to undo the multiplication of 14 and y. I do that with division. So I divide both sides by 14. 14 divided by itself is 1. 1 times y is y. And then again, 14 divided by itself is 1. So what we have now is an ordered pair where y is 1, but we need to know what x is. So you could plug x into a few places just for the sake of proving it doesn't matter which one. Let's plug it into the second equation. So I'm going to get 2 times x plus 8 times y, where y is 1, equals -6. So I'm plugging y into that second equation and solving for x, and that'll tell me what my solution is. So let's see, that gives me 2x plus 8 equals -6. We want to subtract 8 from both sides. So let's see, 8 minus 8 is 0. That leaves me with just 2x equals -14. We divide both sides by 2. 2 divided by itself is 1. 1 times x is x. And we get -14 divided by 2 is -7. So we're thinking that the solution here is -7, 1. Let's just double check with Desmos, okay? Okay, so you can clear out this stuff a couple of ways. You can just hit X and it gets rid of both of those. You can also refresh your screen and it'll let you reset Desmos. I just cleared out using the X. So let's type in our two equations. We had -x plus 3y equals 10. And then we also had 2x plus 8y equals -6. You can see the point of intersection, and we want to see what that point is, so you can either click the point of intersection or just hover over it. So we can verify here that the solution to this system really is -7, 1, okay? So let's stop share. So we've verified both of our solutions, okay? Always make sure you write your answer as an ordered pair. Your reader needs to be able to find the solution very quickly. We also need to know, as the math instructors, that you understand that the solution is an ordered pair, okay? I want to caution you greatly with using Desmos. It's going to feel really compelling and enticing to use Desmos to do homework and just quickly get through it. You're hurting yourself because you're going to have to eventually take tests or quizzes or some kind of assessment. You need to understand the algebra, okay? So Desmos is a great tool to use to check your answer, but you still need to understand the algebra behind it, okay? So yes, Desmos is there. Yes, use it to check your answer, but please don't overuse Desmos.